Hello everybody. Today we're going to learn how to simplify radicals. Basically what that means is what do we do when we're trying to take a square root of a number that is not a square number, like 24 for instance. We know that's going to be almost 5, but it's not quite 5, and so if we use a calculator we can get a rounded answer, but a lot of times what we want to do is just simplify this radical instead of giving a rounded answer. So when we're not going to use a calculator, or when we need to manipulate a fraction or something that involves a radical, we're going to use simplified radical form. Okay, so there's a couple rules for using simplified radical form. A radical expression is simplified if the following statements are true. So the radicand, which is what's in here, 24 in this case, has no perfect square factors other than 1. Okay, so right now 24 has 4 as one of its factors, which is a perfect square. So this is currently not in simplified radical form. The radicand contains no fractions. Well, this one does contain no fractions, so that one's okay for now. And no radicals appear in the denominator of a fraction. Again, there's no fraction here, so we're not concerned about that one yet. But we'll get to it. In order to do this, we're going to need to use the multiplication property of square roots. If a and b are greater than or equal to 0, so that's just a stipulation that if we use negative numbers, this doesn't work because we're not finding square roots of negative numbers. But in the event that we're using positive numbers, the square root of ab, which means the product of two numbers or more, is equal to the square root of a times the square root of b. So here's an example. If I wanted to find the square root of 20, that would be the same as finding the square root of 4 times the square root of 5, because 4 times 5 is 20. Alright, so we're going to use that to find the simplified form of the square root of 72. So the first thing I'm going to do is break it up into pieces. So for 72, I'm going to break that up into, what do we got, 36 and 2, 6 and 6 and 2, and I have 2, 3, 2, 3, and 2. So the pieces of 72 are, I have a 2 and a 2 and a 2 and a 3 and a 3. Okay? And so now what we can do is break this up into some perfect square numbers. So I can put these two 2's together. I could put these two 3's together. And there's just this lonely 2 sitting by itself. And so here we can see that 2 times 2 is 4, and 3 times 3 is 9, which are square numbers. And so we know what the square root of 4 is. It is 2, and the square root of 9 is 3. And then the square root of 2, unfortunately, is just the square root of 2. So 2 times 3 is 6, and then we have this root 2. Whenever you have a number next to a radical, that just means multiplication, just kind of like if it were parentheses or something. And so the simplified radical form of the square root of 72 is 6 times the square root of 2. Let's check out the blue one here. So if we're doing the simplified radical form of negative m times the square root of 80m to the 9th, first, this negative m is not in the radical, so we can just leave that out for now. And then we have 80, which is 8 times 10. So 8 is 2 times 2 times 2, and 10 is 2 times 5. So what we have here is 2 times 2 times 2 times 2 times 5. And then we have 9 m's. I don't want to go and write out all the 9 m's, but it's important to know that if we can put them in square pairs, that's 2, 4, 6, 8, 9, we can simplify. So we have negative m times the square root of 2 times 2 times the square root of 2 times 2, and then this, we'll leave the, well, we can put the 5 in here now. Then we have the square root of m squared times square root of m squared. I'm running out of room. Let me shrink that down. There we go. I'll give us some more room. Times the square root of m squared times the square root of m squared, and then times, we have the square root of m. Apparently I didn't shrink it quite enough here. Let's do that. Okay. Times square root of m. So all these pairs, so we have this negative m here, and from the green one we know that 2 times 2 is 4, so the square root of 2 times 2 is 2. Square root of 2 times 2 is 2. Now we have the square root of 5. Can't do anything about that. Square root of m squared we know is m. And then we have an m. And then we have another m. And then we have another m. And here we have this square root of m because there was an odd number. Okay, so when there's an even number of variables, you can just divide that by 2 to see how many non-radical variables you get, right? So in this case there was 9. So if there were 8, we would get 4. 1, 2, 3, 4. Since there's 9, we have this leftover one that's still in a radical. Okay, so now what is not in a radical anymore? Well, we got this. We got all those, and we got all those. So we have negative, so it's going to be negative, and then we have 2 times 2, which is 4. And then we have 1, 2, 3, 4, 5 m's. And then what's in the radical is the 5 and the m, so we just say multiply times 5m, or the square root of 5m. Alright, let's go on to the next page here. So this is getting a little more complicated, a little more exciting. So we have 2 times the square root of 7t times 3 times the square root of 14t squared. So again, the fact that this 2 is touching the radical sign just means multiplication, so we can kind of break that up to look like this. Oops, times square root of 14t squared. Now, the 2 and the 3 are already out, so I'm just going to pull those over to there. Now, these can be multiplied together, or just put in the same radical. So I'm just going to do that. So we have a 7, and then 14 is 2 and 7, so I'm just going to put 7 and 2, and then we have 3 t's, right? T, T, T. Okay, so the 2 and the 3 can just stay out there for now. And then we have the square root of 7 times 7. We have a square root of 2. We have a square root of t times t. And then we have times the square root of t. Let's slide that over. Two times 3 is 6, and then the square root of 7 times 7 is 7. And then we have the square root of 2, and then the square root of t squared is t. And then we have the square root of t. So we can do 42, so we have this and this are outside of the radical now, so we have 42t times the square root of 2t, which is what's left in the radical. And that is it for that. So let's take a look at the green one. Pretty similar. The 7 times 3 are outside of the radical. What's inside the radical are, we have 20 is 2, 2, and 5. And then we have another 5 from over here. We have x, and then 5 x's, so that's actually 6 x's. Okay, so this 2 times 3, that's 21. And then we have 2 times 2 in the radical, 5 times 5 in the radical. And then we actually are going to have 3 pairs of x's because we have 6, so that makes 3 pairs. So, x times x, x times x, and x times x. So we have 21 times the square root of 2 times 2 is 2. The square root of 5 times 5 is 5. Oh, that's not a very good 5. And then we have times x times x times x. And then we have all this multiplied together. So 5 times 2 is 10 times 21, and then 3 x's. So you can see that up here it looked all complicated, a bunch of square roots and variables and stuff, and down here we see it's very simply 210x to the third power. Okay, over here we have a division property of square roots. So again, if we're dealing with positive numbers, or 0 in the case of A, we can take a square root that is under a radical and turn it into the square root of the numerator divided by the square root of the denominator. Here's an example. Square root of 25 over 64, same as the square root of 25 divided by square root of 64, which would be 5 over 8. So let's put that in action. So in this green one here, we have, we can just do the square root of 144 over the square root of 9, which will equal 12 over 3, which will be 4. And then the blue one here, again, we can split that up. It'll be square root of 36a over square root of 4a to the third. Actually, you know what? Before we do that, I think it will be advantageous to reduce our fraction. So if we do 36 divided by 4, we get 9. And then if we do a on top and 3 a's on the bottom, that leaves us with a squared on the bottom. So it looks like we can do square root of 9 over square root of a squared and get 3 over a. There we go. So we're done with that one. I think this is our last slide here. If you remember back here, the rules state that no radicals appear in the denominator of a fraction. Okay, so this one, can't put it like that. So how do we get rid of this radical in the fraction? Well, the radical is like a square root, so if we could multiply the square root times itself, we would get a whole number. And just like we can change 2/3, if we multiply the top and bottom by 2 to make it 4/6, because 4/6 and 2/3 are equal, we can do the same thing, but instead of multiplying by a whole number, we can multiply by a radical. So if I multiply the top and bottom by √3, what I end up with is the square root of 6, because 2 times 3, over the square root of 9. So the square root of 3 times the square root of 3 is 3, right? Because 9 is square root. So now we are done, because it's okay to have a radical in the numerator, it's just not allowed to be in the denominator. So that one's done. And the same thing can happen over here. Pretty simple. Multiply both by √3, top and bottom, and we end up with 7. There's no square numbers in here, so 21s has to remain that way, and then 3 on the bottom. Okay, so that is it for tonight's video. Thanks for watching.